Okay, good morning everybody. We're going to look at the review here for our statistics test coming up on Tuesday. So for the first section here, we are supposed to use the empirical rule to answer these, or for the first page. Empirical rule is by using the percentages that are between each section. So we have a mean of 500. Oh, yeah. So 500 in the middle. Standard deviation of 75, so 575. 650, 725. On the other side, 425, 350, and 275. The percentages in between each one of these, 34%, 13.5%, 2.35%, and 0.15%. On the other side, 34, 13.5, 2.35, 0.15. Now that we have our percentages, we can answer any of these questions. The first one says, express the probability as a decimal, all right? So these need to be expressed as a decimal. What is the probability that the randomly selected score is less than 575? So we go to 575, and we add up all the ones that are less than it. So this adds up to 50 plus 34, so 0.84. It's supposed to be expressed as a decimal, so it needs to be like this, not a percentage. What is the probability the randomly selected score is less than 425? 425 is right here. We got 13.5 plus 2.35. 13.5%. Yeah. So 13.5 plus 2.35 plus 0.15. So that is 15.7% or 0.157. Okay, what is the probability the randomly selected score is greater than 650? Greater than 650 is over here. So 2.35 plus 0.15 is 2.5, so 0.025. See, I accidentally put this in the wrong place. It's a 2.5%, supposed to be right here, 0.025. What's the probability that a randomly selected score is at least 725? So that's everything below, no, that's everything above 725. Because if it's at least 725, then that's the lowest it can be. So it's 0.01015. Yeah, we need to turn this into a decimal, so we move the decimal place to the left 2 spaces, so it gives us this. What percent, so these are a percentage, what percent of score between 350 and 650? So 350 to 650, so that's all 4 of these added together, 34 plus 34 plus 13.5 plus 13.5, and that's 95%, of course, because that's the empirical rule. Those are within 2 standard deviations of the mean. 425 and 575, 425, 575, 34 and 34, so 68. And then 275 and 725, 275, 725. That's 3 standard deviations. You can add these all up, but we know 99.7%. Okay, for our next one here, we are supposed to be using the z-tables here. So we have to calculate everything using the z-table. We still are supposed to label it. So we have 12 months is the mean, standard deviation is 2 months, so 14, 16, 18, 10, 8, 6. Okay, find the probability 12 and 2. Find the probability that the instrument produced by the machine will last less than 7 months. So we want the area to the left of 7. Now you'll see it's between 6 and 8. So we have to use the z-score. The z-score for this one, 7 minus the average divided by the standard deviation. 7 minus 12 divided by 2 is negative 2.5. So we can look at our z-table to get the probability or the percentage that's to the left of negative 2.5, and it does say express as decimals, so we just have to look it up. So it's 0.00621. So about 0.6%, so not very much. Number 9, find the probability that the instrument produced by the machine will last more than 12.5 months. So 12.5 is like right here. Once again, have to use the z-score. 12.5 minus the average over 2. Okay, so 12.5 minus 12 divided by 2. It's a z-score of 0.25 because it's slightly above the average. So we'll look at our z-table. 0.25 gives us 0.59871. Now that's going to give us the area to the left of this. Okay, 59.8% to the left of this. But the question wants more than 12.5 months. So we actually have to get the other side, which means we have to subtract this from the total, which is 1. So we have to subtract that from 1. 1 minus 0.59871. So there is about a 40% chance that this will last more than 12.5 months, 0.40129. Find the probability that the instrument produced by the machine will last less than 15.5 months. So 15.5 is like right here. We want less than, so we want the left side. Calculate the z-score, 15.5 minus 12 over 2. So z-score of 1.75. We'll look up 1.75 in our z-table. So 0.95994. So the probability that it lasts less than 15.5 months is like 96%. Pretty likely that it will last less than 15.5 months. Find the probability that the instrument produced by the machine will last longer than 9.5 months. So 9.5 is like right here, and we want the right side. So we will have to subtract this from 1. So we take the score, subtract the average, divide by the standard deviation. 9.5 minus 12 divided by 2. We have a z-score of negative 1.25. When we look up negative 1.25 in our z-table, we get 0.10565. Now this is the area to the left of that score. It's a 10% to the left of this. So we have to subtract this from 1 to get the area to the right of it. So 1 minus 0.10565. So we get 0.89435, which is about a 89% chance or an 89% probability that the machine will last longer than 9.5 months. So pretty likely that it will last longer than 9.5 months. All right, and then our last page here, a school newspaper published a story that included the results of a survey of its seniors. There are 800 seniors enrolled at the high school. 40 are going to college after graduation. 60 are not going to college after graduation. So 100 students surveyed. So the data is categorical because the answers are not numbers. They can't be measured using numbers. The answers are going to college or not going to college. The individual or the variable is whether they're going to college or not, which can't be measured. You can't take the average of that. It's not numerical. What is population? Population is everybody. That's the 800 students. The sample is the 100 students surveyed. And that's it for that one. For 15 through 17, which type of data collection you would use for the study? A study of the effects of medication on patients with lung cancer. This is an experiment because you have to give them the medication, so you have to interfere. So that's an experiment. A student where a study where a student wishes to determine what type of fast food their peers like best. So this is probably a survey because you have to ask people questions to figure out what food they like. This is not information that's readily available. You have to ask them. However, if you look at number 17, a study of the salaries of teachers in the state of Florida, teacher salaries are available online. You just have to observe the salaries and study them. This is an observational study. All right, that's it for the review. It was pretty short because we haven't covered a lot of topics here. So that will be it for our review today on statistics.